So you have chapter 10, chapter 11, and chapter 12 left. 10 is on similarity. Talk about similar figures. 11 is on your trig functions. And 12 deals with circles. And then we are done. You guys have 49, including today, more class periods in here. It saddens me. I cry about it quite often. Okay? So, in that time, we'll cover these 3 chapters. All right? Go ahead and work on that. And you can work together. These 2, you're not going to find similarity statement on 10-1, nor are you going to find similarity ratio defined in 10-1. Okay?
Is this someone's birthday?
I don't know. All right, so let's go ahead and work on that. Work with your partners. Here you go. Can I get your attention back up here real quick? Thank you. Hey, when you're defining ratio, remember ratio, let's go through these definitions here. Ratio is just a comparison of 2 things. Okay, so and what we're going to be dealing with in this chapter and what we've dealt with before when we're dealing with ratio is comparing 2 sides. Okay? Proportion, what's a proportion? Andrew?
Statement that 2 ratios are equal.
Good. Statement where 2 ratios are equal. For instance, if I had 4/5 as a ratio, I know a proportion could be 4/5 equals, maybe we just double both of those, make it 8/10. That's a proportion. So what we'll end up having this chapter is where we make one of those variables. So maybe we have 4/5 equals 8/x, and we solve that. Okay, in that case it's easy, it's 10, but we can make it a little more complex where we have to cross multiply and divide. Similarity statement. What's a similarity statement? What's similarity ratio? Nick?
Ratio of the lengths of corresponding sides of similar polygons or solids is the similarity ratio.
Good. So if I'm looking at, say, problem number 1, an example 1 here, and I want to define a similarity ratio. Okay, the similarity ratio, if we're trying to figure out first if these 2 figures are similar, they should have the same similarity ratio when we're combining or when we're comparing sides. So when I set them equal to each other, 15 corresponds to which side on this figure? Yeah, EF. So 15 is 15 to 20. And if these figures are actually similar, then this, let's use a different shape here, 18, which corresponds to 24, okay, that should be equal to that. And then 12 should be equal to, or 12/16 should be equal to that. They should all be proportional. They should reduce to the same thing. Okay, if you were to divide them, you get the same decimal. Now, if I'm reducing these fractions, 15/20, 5 goes into 15, 3 and 4. What goes into this? 6. 6 goes into 18, 3 and 24, 4 and 12. 4 goes into that 3 times, and 16, 4. So 3/4, our similarity ratio is 3/4. This is why I use a pen or a pencil. Similarity ratio is 3/4. Okay? What is our similarity statement? Well, similarity statement, I know it's not really in the book, it just starts describing different shapes as similar. A similarity statement is where we say like ABC, triangle ABC, is similar. That's the symbol for similar. Okay, it's just the top of the congruent sign. Is similar to FED. They're similar. A corresponds to F because those angles measure the same. B corresponds to E because those angles measure the same. And C to D because those angles measure the same. Okay? Questions on it? Okay, tell your neighbor, in similar figures, what do you know about the angles of all similar figures? What you got?
All corresponding.
You know. Huh? You don't get it? Okay, volunteer. All angles are? Yeah, corresponding angles are congruent, right? Good. Corresponding angles are congruent. So A corresponds to F, they're the same. So as your shape gets bigger, the angles don't change. Right? Okay, unlike congruent figures where the shape gets bigger, and the sides have to get bigger on both, you get the exact same measures. Okay? The angles stay the same. In similar figures where the sides actually can change, the angles still stay the same. Okay, so your angles are going to always be the same in similar figures. All right. Number 2, go ahead and show your neighbor what you got there. How many of you have already done that one? Huh? All right, try number 2 there. I haven't given it. It's right here. Number 2. Okay, so you're doing number 2 off of page 496. Okay, are these similar? Yeah, the angles are the same, right? Got three angles that are congruent. 12 is to what? 18. So 12 goes with 18. As 16 goes with what? 21. Good. Oh, 24. Yeah, notice the angles here. This is 1 mark, that's 3 marks, that's 1 mark, that's 3 marks. So this one should go with that one. That should be 24. Okay? And then 14 and 21. All right. Hey, what do they all reduce to?
2/3.
2/3. Good. Okay. Similarity statement. Volunteer. Nick, what do you got?
Oh, similar statement. Triangle XYZ is similar to triangle MNP.
Good. Similar to. All right. Well done. Any questions on that? Okay.
Wait, actually,
What do you got?
does it matter if you got when you switch, like say instead of 14 over 21, 21 over 14, you just have similarity ratio of 3 seconds?
3 to, yeah, so if you flipped them upside down. Yeah, unless they specify this triangle to that triangle,
Okay.
then it would be okay either way. So if you said 2/3 or 3 seconds on this one, you're okay. I don't think it specifies, does it? Does it actually say?
No, it just
No.
says the triangle.
Yeah, it just says the triangle. So if you would have went the other way, that would have been fine as well. Okay? All right. Hey, take a look at number 4. Number 4 on page 497. Okay, it says, what are the actual dimensions of the living room? All right, and they give you a scale factor here. So in order to do this, if they're measuring in inches, if you know 1 inch is equal to 16 feet, you need to make sure you have an inch ruler. Okay, I want you to work with your partner, figure out what the actual dimensions of the living room are.
Oh,
Hey, sorry, my bad. I want to make sure you guys have some background knowledge. For those of you who don't know, this is a ruler. Okay, this from there to there is 1 inch. Now, when you go from here to here, that being 1 inch, this mark right here, and here, and here, those are quarters, right? 1/4, another quarter is a half, 3/4, a whole. This then is half of a quarter, which is 1/8, which then this is half of an eighth, which is 6/16. So 1/16, 2/16, 3, 4, 5, 6, 7, 8/16, which is 1/2. Okay, just so you know. So be really specific and really accurate when you're measuring, and specific when you're marking down your answer here. Okay, be accurate in your measurements, please. Okay, hey, time's up. If we measure this right here for a living room, what's this length? 3/4. Everyone agree it's 3/4?
Yeah.
Okay, what's this length?
1 1/4.
5/4, 1 1/4. Okay. Hey, if they're fractions and they terminate, it's pretty easy. We could actually put them in decimal form. We want 3/4 is actually equal to 0.75, and 1/4 is 1.25. Okay, how do we figure out the actual length of this side? Jody?
You have 3/4, and then that would be equal to the 16, or like 3/4 of 16.
Okay, good. Yeah, so 3/4 is 16. You can multiply them, right? Nick?
What I did was, so if 1 inch was equal to 16 feet, then I put an equal, and then I put 3/4 of an inch is over x, and then cross multiply and divide it.
So you did 1 over what?
16.
16. So you're comparing inches to feet?
Yeah.
Okay. And 3/4
Over x.
over x. Good. So it's a proportion. It's kind of a weird looking proportion, right? Because we got that compound fraction in there. But yeah, so you get 1x when you multiply across, and 16 times 3/4, or 12 feet. How many got 12 feet there? Now how many did this a different way? Maybe just multiplied the two? Okay, that's okay. But it's helpful if we're not quite sure what to do. We have this proportion, comparing inches to feet. So in this one, that would be 1 inch to 16 feet is equal to 1 1/4 over x. So once again, we get x equals, and then this is 20 feet. Okay? So we have 20 feet, we have 16 feet. Okay? So it's 20 by 16. What's our area? DJ?
Isn't it 20 by 12?
Yeah.
20 by, is it 12? Oh,
Yeah.
my bad. Thank you. 20 by 12. Yeah, so that makes this 12. Unbelievable. Yeah, so 240 square feet. Okay. So when you're dealing with plans, or maybe plans for a house or something, you're trying to figure out how much carpet you would need or something like that. That would be something that we'd use. You could also use that when you're dealing, if you actually had the dimensions of a wall and you're trying to figure out how much paint you'd need. Okay? All right. That's about it for similarity. How many know how to cross multiply and divide? Solve proportions. Okay. How many think you're pretty good at it? You're like, I'm okay. Okay. Let's take a look at this piece. This is out of your book. If you want to, it's on page 499, but I'll leave it up here. The question is this: if A over B equals 3/4, which of the following are true? So I just need a true or false. Okay? There you go. They start off easy. They get a little more complex. Work with your partner. You guys get about 5 minutes. If you're struggling getting started, guys, if we know A over B equals 3/4, what's the first step in solving a proportion? Yeah. Go ahead, Jody. Cross multiply. So we get 4A equals 3b. So that'll be a hint for some of you. If you can make these equal 4a equals 3b, then they're equal to that. They're true then. Okay? So, keep working on it. They get more difficult, but on most of those, start by cross-multiplying. Hey, it hasn't quite been 5 minutes, but let's go through the first half of these at least, okay? So number one, true or false?
True.
True, yeah, it's right here, right? True. Number 2,
False.
can we make it be this? No, that's false. Okay? Any questions on that? This one, by the way, like if we undid that, that would be, right, so if this is A's on top, 4 is on bottom, A and 4 are on different spots, right? Here, 3 and A are at different levels, and that's not true. Everyone see what I mean? So in order to get this, I'd have to have 3 and A, like that, and 4 and B. Okay, which is not what that's saying. Or flip the other way. It would either be that one or it'd be 4 and 3 and B and A.
To get it or not?
To get that. In order for...
3 be on top.
Yeah.
Yeah, 3 would be on top. 3 over 4.
3 would, yeah, thank you. 3 over 4. I really need to get my pencil back up here. All right. How about this one? Cross multiply, I get 3b and 4a. This is true. Is this one true?
Yeah.
Yeah. 4a equals 3b. True. All right. Well, how about this one? 4a equals 3b, right? Cross multiply them. Is that what we're trying to get? Yeah. That one also is true. How about this one? Yeah, this one's false. I mean, you could divide by 4, you get a over 4, and divide by b, you get 3 over b, or divide by 3 and divide by a, or something like that. This one is false. You can't make that equal 4a equals 3b. Okay, how many are done with 7 through 10? How many are stuck on them? Okay. Hey, if you're stuck on them, still try to cross multiply. That's your first hint. And then try to make it equal 4a equals 3b. Okay? So give it a shot. Try number 7 there. You haven't done it yet. Give it a shot now. Okay, I cross multiply. Hey, when I cross multiply 4 times AB, that's like this. A plus B. 4 times A plus B. And B times 3 plus 4. What is 3 plus 4? 7. So that becomes 7B. Does that equal that? How many got that? How many cross multiply? How many tried to cancel these B's? Can't cancel the B's because you have to cancel the whole A plus B. You can't cancel the 4's. Right? So this is 7B. That's 4A plus B. When I distribute this, what do I get?
4 plus 4b equals 7.
4A plus 4B equals 7. B. Does 4A equal 3B here?
Yeah.
Yeah? Maddie, how do I get that?
Subtract 4b from 7b.
Yeah, subtract 4B from both sides. I get 4A equals 3B. Which is that, which makes this true. A little more complex. Try number 8. Give it a shot. Remember, you cannot cancel these A's. You have to cancel the whole top. There'd have to be an A plus B on the bottom in order to do that. Okay, how many say true? False. How many are just staring at it waiting for it to get done? Come on, man. So what's 3 times A plus B? 3A plus 3B. What's this? 7A. So 3A plus 3B equals 7A. That is not 4A plus 3B, or equals 3B, is it?
When you subtract 3A.
Oh, let's subtract 3A. Let's check. If I subtract 3A, I get 3B equals 4A. Is that what we want?
No.
Yeah.
Yeah.
Wait. Yeah, sure.
Is it okay for the 4A to be on the other side?
Yeah.
Yes.
There you go.
This is true. How many said it was true? Okay. Number 9. Is number 9 true?
No.
We're getting a little better at distributing. What's this times this?
3B plus 12.
3B plus 12. What's this times this?
4A.
4A plus 12.
Subtract that 12.
Subtract that 12. We had 4A equals
3B.
3B.
Yeah.
It's true. Woohoo! True or false?
True.
True?
Yeah.
6/8 reduced to
3/4.
3/4, which is what that is up there. So we're good. This is true. A lot of trues, 2 falses. Okay. Questions? All right. Here we go. Here is our